Before we get into the actual details of the communication system and the fundamental elements of a basic communication system, let us actually establish a correlation between the biological communication between individuals, and then we go on and develop the model of electronic communication systems. Now let us consider two individuals, two persons A and B trying to communicate with each other, and let us say that they are at a distance of a very quite comparable range called as D. Now if A wants to communicate some kind of information to that of B, initially the brain of B generates that signal, and through a nerve it gets into the mouth of this particular user A, and the mouth here tries to convert the message which is generated in the brain into an electronic signal, which is typically a sinusoidal signal coming out from A. Now here the mouth of A is acting as a transducer. Now similarly, the B, when it is taking or receiving the information, it has got the ears, the B has got the ears which interpret this data coming in the channel through its ears, and here the ears of your B act as transducers again, and then from the optic nerve, from the nerve system, it goes into the brain of B, and the information is interpreted what A wants to communicate. Now similarly, in a typical communication system, we have a source of information which I correlate it to the brain, and then I have the transducer which is trying to convert the message into a form of audio signal, and then here again I have at B the ears as the transducers which are converting the information from A into a form which can be disseminated by B. Alright, so having considered this basic form of communication, when A speaks it out loud, B is automatically able to hear it because B is at a distance in a very normal range to A. Now let me consider the second case of this illustration, wherein A and B are going at a distance beyond D. Now let me call this communication as the D of A comma B, where D is the distance between A and B, which is enough for establishing your communication. Now let us consider the second scenario, wherein the distance between A and B is now increased to a value called as D dash. Now as the distance is increasing, the amplitude of this particular signal which disseminated from A decreases in strength as it travels, and then it gets received at B at a very low level of amplitude. Now here in this case, B might be having an interpretation, B might be having a deception in interpretation, wherein it cannot completely decode the information which is sent by A. Now what happens in this kind of system? So in order, as it was like the distance was going on increasing, now they wanted to have a kind of communication wherein they just had, instead of a wireless media between A and B, now they want to have a very secure means of communication, secure channel of communication, or secure wire of communication. So thereby they built a kind of system wherein they can talk here on one side of A, and now this becomes the second transducer of converting your audio signal into a kind of electrical signal, where I am joining on the other end. I'll have another transducer which is attached to the ears of the receiver. Now the kind of signal which is emanated here is converted into a kind of electrical signal which passes through this particular wire media, and now B is able to hear the signal, or B is able to hear the voice from this particular A in a more better way than before, as the distance was increasing. Now I would call this kind of communication, the communication between A and B is wired with a distance of d dash. The things are lot simpler in this kind of communications, but in a real time world the life is not so simple. It gets more and more complicated as we get into more and more real time scenarios. Now let me consider one such consideration of having a wireless media and the distance now been increased to a far greater value called as d double dash. Now let me show you this scenario. Now let me consider the third scenario, wherein I am trying to have, apart from the user A and B, I have a car which is coming up in the opposite direction. Maybe say A is going in this direction and B is going in this direction. Now let me consider this real time scenario, wherein now the signal coming from A is intercepted by another source of signal, which I would call here as a noise. Now if the signal is, now let me, I'm again considering the same old wireless media for our practical purposes. So the signal which is emanated from A is now reaching B, but not only this signal A which is coming from A is reaching B, but also a signal which is because of the noise, because of the horn sound, is also acting as a signal, and this is getting superimposed on my original signal and deteriorating the signal quality at B. Now this is what I call it as noise. Noise is something which is an unwanted signal. So B receives the signal from A in a attenuated manner. Along with that, it has got an extra signal which is unwanted to B, which I am calling it as noise. Now let me make this point very clear. Noise is a relative parameter. Now what do I mean by this? When I say noise is a relative parameter, now let me consider my car as another source of signal, having another source of signal C, and let me assume another case, improvisation for this case, where I have a stranger crossing the road. Now as and when the vehicle sees this particular stranger crossing the road, it blows the horn. Now as I was saying, that noise generated, that signal which is generated by the horn is a noise to the signal which is going towards B. But then this particular signal which is coming from C is actually original signal to this particular user called as D. So a similar kind of signal can be a wanted signal for one user, but whereas an unwanted signal for another user. So as in this case, the signal which is coming up from the source C is a wanted signal by D, but whereas it is considered as noise by the second user B. Similarly, signal which is coming from A is a wanted signal for B, but whereas this is becoming a noise for the user D. So this, I stress upon this particular parameter, which is very, very important in communication systems. Noise is a relative concept. Noise is a relative parameter. Having said this, now I would say I have basically a transmitter. I have a transmitter at the sending end. I have a receiver at the receiving end. But apart from these two, I also have a channel in between, a medium in between, which is modeling your signal. I would say it is modeling your signal. Now, why I am saying it is modeling your signal is, it is not only your signal which is coming up with a decreased strength, but it is also an additive mixture of signals from various other sources in the channel. Now, having said this, let me take you to one more illustration of making you little more intricacies of communication system more and more clear. Now, to explain you the current concept of this particular communication system and to add little more blocks to it, now let me tell you a typical example of a war scenario between two kingdoms. Now, in earlier days, when we had the kingdoms and kings and palaces and empires, we had this basic thing that if at all a particular king of a kingdom wants to attack another king or another empire, he used to have a kind of communication being sent from one king to the other king. Now, let me say I have a kingdom with a king K and I have another kingdom with king J. Now, there has to be some kind of communication between the two users. Now, the user 1 is king K and the user 2 is king J. So, he used to have a kind of messenger being sent to the other end of the second kingdom with king J. This particular messenger used to carry your information across all the villages, across all the space between the two kingdoms. And now, if at all the messenger reaches that particular second kingdom, whatever the information that the first king wants to convey to the second king is approximately delivered. But then, if something happens to this particular messenger within his propagation duration across all the villages and all the stuff, then there is no chance that this particular message from K reaches J. So, this is a very, now the two kingdoms are very far apart and we are considering a situation, an extension to the previous situation, wherein now my distance d triple dash has become far more than the other two cases. In this case, the only way you can convey your message from one end to the other end is by sending your messenger. Now, that is one thing. This is becoming very tedious. So, the second way of communicating between two empires, they've built something called as towers or tombs in between. Now, let me say this is tower T1, T2, T3 and T4. Now, in this kind of communication, the messenger at the kingdom shouts aloud the message, and here I have second messenger at tomb T1, third messenger at tomb T2, fourth messenger at tomb T3 and fifth messenger at tomb T4, and finally he takes up the message to the receiving end. Now, in this way you are increasing the reliability of the signal being transmitted from your source end to destination end. Now, again, the problem with this kind of communication link here is there can be more amount of excess distortion of this particular signal in the form of noise being added at every place. Now, this is the kind of model I have for a typical long distance communication system, which I would call it as an amplifier or simply a repeater. Now, what is this repeater or an amplifier doing here? your repeater or an amplifier is trying to regenerate the signal after every short interval of time, now breaking up this entire d triple dash of distance into small distances of d each. So here the reliability of the signal is more, but similarly the chances of getting attenuated is also more. So finally, even when this kind of reliable network is also not working between two kingdoms, then they have gone up and taken another mode of communication, which, like, I have a messenger now, but for this messenger they have given a horse. Now, as the distance is increasing, the messenger is taking up the information on this horse and moving towards destination. Now, what I can compare this horse to? Now, this horse I can compare it to a high frequency carrier, and now this messenger carrying the message, now I would consider it as a low frequency message. So thereby comes a concept called as modulation. So modulation is a process of keeping your low frequency message information onto a high frequency carrier such that it will carry at a faster rate and to a longer distance. Now, having told about this, the basic concepts of your communications, now let us get into a brief block diagram of all the things, all the possible things in a more compact way to form an electronic communication system.